Hello, this is I, your internet friend, Robert Gadarian. Today we're going to do a somewhat complex example of recursion. And this is really the motivator for why we teach recursion, that it is a useful tool. There is times where it's inescapable, and there's times where it's just quite beautiful to use. So yeah, it's not just a trivia item saying, hey, well, we could solve this recursively. Imagine a file system. Totally not hypothetically. The only things on a file system are either folders or files. Files are things like Word documents and I don't know what else you'd have on your Python documents. You probably have a few of those. Text documents, system files, etc. Or there's folders, and folders can hold folders, and files are just files. So in a not hypothetical way, here's my desktop. And I have my teaching folder, and I have a whole bunch of stuff in here. And then I can go into a folder. And then I have the same problem again. I have a bunch of folders, and then there is a file in here. And here's another folder and a bunch of files. Folder, file, folder, file, folder, file. And at any point, if I'm looking at a folder, I can see its contents, and I'll see it's all files or folders. I can look at this one. It is all files or folders. And finally, I can get down to an endpoint where, oh, there is no more files to visit. We're at the bottom. So the problem that statement is, that we're solving today, is that I want to be able to list all the files, the individual files down at the bottom, that are inside my folder. And to do that, if we start up here, I would have to answer that question again. I want to list all the files that are in this folder. I want to list all the files that are in this folder again and again and again. And once we get there, we can start opening these files and saying, what is inside this file? Or we can say, does this file name exist inside of this file system? So there is no good way to solve that using loops. It's possible, but it's gross, and you don't want to do it. So you could actually, there's something called a tree command in, if you have a command line shell, and you can actually list everything, which is kind of cool. And you can view it as a tree, and that is exactly what it is. We will visit this, and we'll visit all of its branches. And then we'll visit this file and all of its branches, this file, all of its branches. So it is a naturally recursive problem. So what we're going to do is print out every file name, or what's called a path, all the way from whatever our start point was. And we could either, like I mentioned, look for a certain word inside of a file, and there's a command line tool called grep that does this for us. Or we can actually look for just file names, and you can mix with find and grep if you're a Unix nerd, and no one here is, so we'll just do it ourselves. Blah, blah, blah. Is this realistic? Yeah. Every programming job I've had to do this at some point. And that's because files are just naturally everywhere. If we have a building, we can imagine that it's got a bunch of sensors. And those sensors might be stored in a bunch of folders. So we have a building. So this is building 1. And then there's a bunch of floors. 1, 2, and then floor 4. Why did I do so many floors? And each one of those floors has a bunch of rooms. And those rooms have n sensors. We have sensor 1, sensor 2, sensor 3. And then in here we have daily logs of what that sensor says. Well, this looks like a file system, and if we're looking for a certain thing that happened inside of all these sensor readings, we'd have to write a program to do it. And this is not hypothetical at all. I have seen exactly this setup at the university, and I have traversed this data points. Next time at the university, especially one of the new buildings, look at the thermostat on the walls that controls the temperature of the room poorly. Though that is logging at all points, and those logs are all stored, and you can get access to them if you ask nicely. Okay, so we need to be able to look at the file system. Python has an import for that. Python has an import for everything. This is an XKCD, and you take some time to read it. So we're going to look at the OS module. And this stands for operating system, and we can get the current working directory, which is literally the folder that we're in right now. And if you've messed around with Spider enough, you've probably run across this at some point. So I'm going to make a new file. Oh man, that new file smell. Do you smell it? So print, I'll actually just do this, os.get current working directory. Of course, written in a very arcane way, and it's going to name this fs.py for filesystem.py, which is also arcane. And then it'll give me the folder that I'm in, and that is indeed true. That is where we are. So now I can see that I can inspect directories. Well, that's important because we need to be able to do that. I also have to be able to mash these paths together. And luckily, Python makes that easy for us. And this has to be platform independent. Windows uses slashes that are the wrong way, and Unix and Mac included in that uses slashes the correct way. The correct way is the way you see on the internet. The wrong way is what you see on Windows. Prove me wrong. So if I have two paths, it'll actually just give me a nice properly slashed path, this slash that. You didn't see that at all. And it'll print out what we expect. And that's good. And if there's spaces in the file name, it'll work itself out, which is something that I don't have a problem with, but most people do because people put spaces in file names because people are normal and I am abnormal. Not special, just abnormal. Okay. So the path will help us with this too. That's excellent. So now we need just a few different tools. os.listdir will give us the listing of a directory. So I'm going to have a constant up here. I'm going to call it start point. And I'm going to make that equal to users. And you'll have to do this differently on your computer, obviously. Users, Rob G, documents, OneDrive. No. Yes, that'll be fine. No, it's just here. It's a OneDrive here. I have a new setup and I don't like it. I'm using OneDrive. It's kind of nice. Okay, so that is my start point, and I want to be able to print os.listdir, and this will show me start point all of the files and folders that are in that starting file or folder. So .dsstore is a Mac thing. You'll see that I have teaching, work, and TMP, and then what looks like a UUID, which is something that we're not going to talk about even though I want to. And is that true? If I go to my OneDrive folder, which is actually here, I'll see that that is true. And it comes in as a list. You can see the square brackets. Good. Am I sharing my whole screen? Hopefully you saw that. And, all right, I'm happy with that. That means I can move on to the next piece. os.path.isFile. That must ask if it's a file or folder, and an is folder. I only actually have to use one of those. It's nice to know I have both. Okay. So now I have tools. I have a mission statement. Now I need a plan. So what I have is a folder. I'm going to call it OneDrive, OD. And there is a bunch of files or folders, F1, F2, F3, and then a file, which is actually approximately true. And for each one of these, I need to listdir. And then if it's a folder, visit. And that's going to loop us back to the first question again, recursively. Else, or you can say use the is file, will just print the path. Ooh, that sounds like a base case. Doesn't it? This doesn't sound too bad. But we do have a loop inside of our recursion. Okay, great. So I'm going to say def traverse. And I'm going to have a folder. I'm going to pass in my start folder at first, but I'm not going to just stop there. I'm going to debug as I go. So I'm going to say for a file name in os.listdir, and I'm going to say that, I'm going to assume that this is a folder that I can list. I'm going to print my file name. And that will presumably do that. And then that's all I'm going to do for now. No recursive call. And I'm just going to test that this works. So I'm going to traverse my start point. Oops. And let's run it. Okay. It prints out this. So I'm going to get rid of these debuggy things. I'm going to comment them out because I don't need that. I do need this eventually, and I have already used this, but that's fine. There we go. So now I have everything that is inside of my start point. I actually don't want the whole thing. I'm going to put you into teaching. In teaching 1012. Seems very topical for this course for some reason. Otherwise, it gets a little bit unwieldy. Cool. All right, so now we have that. We have that. So now I have to decide. Now I have to make sure that that path actually exists. It does. I see it. I have a shortcut, so I'm gonna have to actually use this. They have all this gross, nasty. Where is it? Oh, it's in my documents. This is the actual path to it. I just shortcutted it. Documents. Blah. And I'm going to pause because I have a phone call. Okay, we're back. Press play on this, and no such file or directory. You know what I should have done before I unpaused? Make sure that directory exists. I'm going to make that work, and then I'll be back. And there we go. Okay, so now I can see labs, assignments, tests, admin, and some control files that have dots before them, which make them disappear, which is kind of cool. But they still qualify as files. Okay, so now I have a bunch of folders, and if I want to see this in a directory, I went to teaching, and then this course. These are the files I'm seeing. So now I have to say, okay, if this is a folder, I want to go through it. And I'll go through all these, and these are all files. So they'll all just get happily printed out. I'll go back to here, and then I'll say, oh, these are all folders, and then, oh, there's a folder, and then we'll have to print them all out. That is a for loop. So I'm going to say, using os.path.join, wherever I am, plus whatever folder it is, I'm going to see if it's a folder, go visit it. So if, okay, first I'll make the path, new path, is equal to os.path.join, where the heck I am, plus where the heck I'm going. And then if os. Do I have my helper? Path.isFolder. Oh, isdir directory. Another word. Same thing, just different. All just words. And then, hey, it's helping me. Path _ path type. So great. What I want to say is this is my new path. So if that path is a folder, I want to visit it. This is my recursive case. Traverse my new path. Otherwise, this is a file. I'm just going to print out my new path. Bang. Oof. I have all this .git stuff. I might ignore that one file because it's the majority of the output, which is a little bit gross. I can change my start point to be lectures or assignments. And that will look like that. Oh, and it's a huge, huge, huge path. But you can see your A2 mystery files, assignment 1, assignment 2 mystery winning numbers. And they're all here and kind of in a gross format. So maybe let's, we don't even have to see the whole new path. I'm just going to say print my folder, which will be actually potentially not a folder. These are all, oh, sorry, file name. Print my file name. That will be the end file name of everything and all the way through everything. Totally impressive. So when I introduced this problem, did you think that I could solve it in 10 lines of code? Probably not. You say, that's a big problem, but it's really not. And that's the incredible thing about recursion is if you spot the recursive nature of going through folders, all of a sudden it's not that hard. And all of a sudden it's maybe okay. And these are all the things. And this is approximately the same code. And that's it. 2 cases. Are you a file or are you a folder? If you're a folder, I'm going to visit you and visit everything in that folder and say, is this a file or is it a folder? And that's it. So this is further than we go. Don't memorize anything about import OS. This is just to show you that there is real meaningful examples of this in real life. Have a good day.